Well, he might have had the sunblock on. This is just it's just color, not. He got the good rays, not the bad rays. You have to put sunblock on?
No.
No, he didn't.
I
He's,
put
he's
sunblock
gone.
on,
He's a
it
guy.
didn't burn.
You what?
Like, I put the sunblock on and it didn't burn.
Yeah, but it sounds like you wasted your time even being out there. He does track as well. You do.
No.
Yeah, because
He does track.
runner.
Yeah.
Yeah, he looks like a runner. What place did you get?
I ran the DMR, which we took first, then Casco record, and 1500 didn't go as well though.
How did you do personally?
Which one?
The one that you guys got the school record and got first.
Pretty good.
All right.
1 second away from PR.
All right. So he's like on a winning team, right? Where you're out there just throwing heavy chunks of metal. When you can do that, there's like probably places you can work for where you just move rocks around.
Well, the Flintstones are probably
Yeah, but then you probably go the lazy route and want to drive the tractor guy. That would be really fun, I think, for like a weekend to just drive like the shovels, the power shovels. You didn't have those in Guatemala, did you?
No.
You had a wheelbarrow and it didn't even have wheels. They had to go behind him and just drag it. They were the modern day equivalent of like oxen. Ay. All right, what was the homework assignment? Integer to base. Is that right? Decimal to base. Is that right? Yeah, decimal to base. All right, so you take an integer representation of a number, and as well as the radix you want to convert it to, and you should return a string that is that number converted to that base. Does that sound accurate for what you guys did this weekend while I was golfing and he was losing? He was winning.
I didn't do it in high school. It's my second year doing it.
These are just excuses.
All right. I'm getting better.
No, I don't believe it. For you're halfway to world record.
Well, it's the world record. It's super impressive. Always wouldn't be the world record ever.
I'd like to say I might be able to get closer than halfway to like the sprinting world record, but I don't think that's true. Maybe like 50-yard dash. No, probably not. Those guys, man, maybe it is impressive, but I'm fat. I got an excuse. You have nothing.
I'm fat too.
I think that helps you with throwing chunks of metal. Okay, so let's go. We wrote our algorithm last time, right? So here's the decimal to base algorithm. We talked about what we needed to do this. We're going to keep doing something, keep dividing over and over and over again until we finally get to 0. That kind of tells us what our exit case is. We're going to be building up our string in reverse, or we're going to be required to reverse it in the end. I think we have an example here, right? Oop. Well, I said at some point this would be a good quiz, right? The converting from like crazy binary to hex or something like that. We looked at the 3 and 4-bit conversions for binary to octal and binary to hex last time, right? Yeah, so that would be a good quiz at some point. You missed that. You should watch the video. I can tell you didn't watch the video already. Yeah. Were you going to lie to me?
No. I didn't watch the video.
I've already called you out on it. This is garbage. All right. So, in any case, we have 11. Converting it to base 2. This would come in as an int. It would return the answer as a string. We divide by 2 over and over and over again, recording the remainder, and then moving down until we finally get to a 0. Then we know we have our final answer. Our final answer is read from the bottom up, so we're building it in reverse. And for us, we'd be returning this guy as a string. All right, sound pretty accurate to what we're supposed to do? All right, and this should work for all bases, including hex. So let's start off making it work for binary. So we'll say static string decimal to binary. Just say that as a starting point. Then we'll adjust it to work for all of our bases. All right, and we're going to take in an int decimal number as a parameter. We'll go ahead and write our loop. We're going to say we're going to do something over and over and over again until our decimal number is finally equal to 0. So while decimal number is not equal to 0, let's do some stuff. What are we going to do each time? We're going to divide the current number by 2, record the remainder, then whittle it down by dividing it by 2. All right, so we're going to need a place to store our answer. So let's call this string answer, and we'll start this guy off as the empty string. Now we'll go ahead and we'll say answer is equal to answer concatenated with, so we're going to not build it in reverse initially. We're just going to keep concatenating on like we've done up to this point, and then we'll talk about the trick we can use here. So answer is equal to answer concatenated with decimal mod 2. So we get the current remainder of decimal divided by 2. Then we'll divide decimal by 2, storing the result back in decimal. That's the integer division of that guy. Make sense? We don't want to whittle it down before we get the remainder, otherwise we'll be getting our remainder for the wrong value. All right, so answer is equal to answer concatenated with decimal mod 2. Decimal divide equals 2. Loop back up. Is decimal 0 yet? If it's not, do this again. All right. Now, if we were to return this answer right now, we'll go ahead and return answer. It's almost going to be the right answer, except it's going to be reversed. All right, so let's just get rid of this stuff. And we'll say int num is equal to 11. System dot, well, let's do this. String answer, woo, that's weird. String answer is equal to driver dot decimal to binary num, and then we'll do a system.out.println answer. Okay, and so that guy will look like that. If we go back to our example in here, the correct answer is 1011. Our current answer should be 1101. We're building it in reverse and not fixing that. Okay, so we'll go ahead and run this. There's our 1101. So we built it in the wrong direction. Right digits are there, it's just in the wrong direction. So what we can actually do here is when we're building up answer, and I think I gave you this hint last class, I said that the empty string is your friend. I mean, you can certainly, down here, you can call, do we still have our reverse function? We had it at some point. We probably just took it out. I mean, we can write that real quick. Static string reverse string s. String answer is equal to the empty string, and then do for int I is equal to s dot length minus 1. I is greater than or equal to 0. I minus minus. So we'll walk our string from the end towards the beginning. Concatenating on the current value of I, or current value position I from S, then ultimately return our answer. So that should be pretty close to what we wrote previously. And then what we can do is just say driver dot reverse, passing it our answer here. So now we'll have the correct answer because we'll, arbitrarily just reverse it at the end instead of building it in the correct order to begin with. All right, so there's our 1011. All right, so now what can we do to not have to do a reverse here at the end? Instead, what can we do to build our string properly in reverse? When we're concatenating stuff on, what can we do to build this guy in reverse? I assume at least a few of you did it in your homework assignment. And I also assume those same people have vocal cords. And I'll take the traditional quarter, oh, you lived up to it, the quarter raised hand.
Don't just concatenate answer on the other side of the decimal line.
Okay, so you want to do this? Okay. So before, this will work for starters, but tell me why this works first. I've taught it the correct way, but it's a common misconception for beginning programmers that the thing on the left-hand side of the plus operator must be a string. That's a common misconception. I think I've explained it with the concatenation operator. Java determines that this is concatenation rather than addition if at least one side is a string. All right, so in this case, the right-hand side answer is a string, therefore it will treat this guy as well. It'll treat that guy as not mattering in terms of what that guy is, therefore this will be concatenation. Okay? Alternatively, if you don't want to have to remember that, you can use the empty string. Take the empty string, concatenate onto it this, and then concatenate onto that the new answer. All right, so then you're forcing it to be concatenation. So if we build it this way, now it will build it correctly. So you're concatenating the new element onto the front of the existing string. Make sense? All right. So that's for base 2. How would we make this work for base 8? Exact same way, but divide by 8 instead of divide by 2. Don't have to change any additional code. What about decimal to decimal from base 10 to base 10? Yeah, waste of time in many cases, right? That effectively converts an int to a string. How else could we convert an int to a string? If I had the integer 11 and I wanted to become the string 11, how can we do that? So if I have the int num is equal to 11, and I want to convert this guy to be that value. Go ahead.
Add an empty string.
Yeah, concatenate onto the empty string. So that's our quick, easy way. If I want to say string snum is equal to num concatenated with the empty string, or the empty string concatenated with num, either way. That'll give us the string representation of it. I think I've at some point said that Java is a string-based language, and if you can get stuff into a string format, it's extremely malleable. We can do things with it, and that's why we're spending time doing string manipulation type stuff. All right, so punchline there is we don't need a function, decimal to decimal string, that converts a integer decimal into its string equivalent. We can just do it with concatenation. But punchline for us is, since the way math works is compatible with whether we're converting from base 10 to base 2, or base 10 to base 8, or base 10 to base 10, base 10 to base 3, it's all the same. What if I'm going to base 16? How do things change for us here? Because we're supposed to be writing some code that converts from decimal into any base. Okay, and how would we actually incorporate that into our code? So if I change this to decimal to, we'll just say to hex for right now, so we're assuming it's going to be base 16, we would do divide by 16 and mod by 16, right? How would we modify this to make sure we took into consideration the hexadecimal alphabet? Every one of you should have done this for your homework assignment as well. Go ahead. Okay, you can use our int to char function that we've already built. And what would you convert from an int to a char? Which portion of this? Well, you're referencing that we have a function already called int to char, right? We wrote one. There's char to int. We want int to char.
For our homework, yeah, we did in class.
Oh, you had to write that in class. Okay, so we'll go ahead and write it. Static char int, what did I say? Int to char, like that, or whatever. Int num. My question still stands. Where do I need to use that in here? But we'll go ahead and write this guy real quick. So we're going to take in an integer, and we want to get the equivalent char, right? So maybe we do something like string map make this guy a little bit future-proof. And we'll return map.char@num. All right, so remember we talked about how char@'s the inverse of index of. So if I say give me the character at bucket 3, that's going to be 3. Give me the character at bucket 10, that's going to give me an A. Give me the character at bucket 15, that's going to give me the F. Make sense? All right, so that's our int to char. Now, where would I use that in here in order to make sure I properly do this? Go ahead. Okay, so this guy right here has the potential of being 10 or 11 or 12, that kind of stuff, right? So we need to make sure that we've passed it through the appropriate filter to convert it into a letter if necessary. But if this guy boils down to a 3, does it hurt anything saying convert the int 3 into the char 3? Not for all, a char is still going to make this concatenation thing concatenation. So we'll go ahead and just say driver.int to char of that. All right. So this should convert a 10 into the letter A and so on and so forth. All right, so this will be decimal to hex. So if I come up here and we change this to hex, what's my favorite number? 2989. That gives us our BAD. So proving we can go back the other direction. All right. So now to complete the homework, we can say decimal to base. And this guy would take in a radix. We'll divide by radix. Well, modulo by radix. Divide by radix here. And now we'll have this guy working for any base. So here's our decimal to base for that number and 16. BAD, if I want that same number to base 3, there's that number, so on and so forth. If I want it in base 34, to JV. Speaking of JV, is that you're on the JV team or the the real deal?
Real deal.
Wow. I wonder how far I would throw it. Like, it was like 10 feet or something. Like, yeah, you're a big talker. 10 feet, and then I'm like limping off of there with back spasms. Because you're not supposed to throw it like you like rip your rotator cuff.
Yeah.
It's like you got to do the big swingy around thing.
That's
And then
right.
shot put, you do it
It's
like,
essentially like shot was like a bench press almost.
Yeah.
Your wrist turn.
man,
Can't do that. You'll just wreck.
yeah, everything's gone. But then I can retire on top. Well, maybe on top if you only threw it like 10 feet. Is 10 feet like horrible? I mean, like, would I be able to throw it 10 feet or maybe not? Okay, so I could. What would you guess I would throw it? Like legitimately?
Probably like 20 feet.
Oh, really?
It's a little over 9 meters.
And your personal best was what?
12.5 meters.
Okay, well, I'll convert that. Is that 30? You said 38 feet? What was your personal best? You said.
It was 12.5 meters. So
Oh, you were just making up the other number.
no, it was 39 meters for hammer.
Oh, 39 meters.
Yeah.
Oh, I gotcha. So 20 feet is like an embarrassment compared to that.
Well, I was saying shot put for you, like 20 feet.
Do they have anything that has like a gun? You shoot stuff? 'Cause I see
That
that.
would
On,
make the sport more interesting. Like you throw it and then you have to get up there and shoot it.
well, isn't that the same thing with the pod racing in Star Wars? You got the Tusken Raiders there, like trying to blow up your ships as they fly by. They need to introduce that to NASCAR. There's like a whole obstacle course they have to go around. Wouldn't that make it like way more entertaining?
There aren't a few right turns too.
Yeah. I mean, same thing with like most sports, like golf. I mean, I find golf interesting to watch, but I mean, for most people, it's boring. But I mean, you start putting like dangerous animals on the course. You know, all of a sudden, like, okay, you know, Phil Mickelson just starting his back nine, and you know, a tiger has been shadowing this group. And every now and then they have to like go through like a monkey blood sprinkler or something. It's like really attract the animals in.
Make sure they haven't eaten for a while too.
Oh yeah, I gotta make them hungry. That's true. There's actually a pro golfer. His name's Boo Weekly, and he's basically a hillbilly. And in a lot of the courses these guys play on, you know, there's alligators, and they can take relief. Like, you know, they can't put themselves in danger. He'll go over. There was another player that the alligator was coming at him. He went over and just grabbed the alligator, and you know, like started teasing him with it and stuff, and just threw it back in the. And it was like a big alligator. You know, it was like, you know, not something that would probably eat a human, but like, you know, like
Do some damage biting it.
yeah, like I mean, like 7 feet long or something. You know, not like a baby. Man, I like this whole, you know, extreme golf idea, especially with like hunting cats. Because it's not fun if it's not something that really do damage, or bears. You know, every player has to carry 30 pounds of salmon in their golf bag just to keep them interested. All right. Questions about that? So this was effectively the homework assignment. We segued it, but we were talking about tiger attacks. I'm right back to. All right, so this makes sense. All right, so let's keep trucking here. All right, so that's our decimal to base. All right, we've introduced index of charet. Okay, so let's keep on with string manipulation. Let's assume we wanted to write a function called substring. And substring was going to take a, so maybe the function looks like this. It returns a string called substring, takes a int as a parameter, and we'll make this guy static. Okay, it takes an int as a parameter, and this guy would return the string starting at position pause all the way to the end of the string as a new string. So we're gonna, if we had the string hello world, for example, so this is position 0, 1, 2, 3, 4, 5. If I passed in a 6, it would just return world for us. Does that make sense? All right, so we're going to write our own substring. We're actually going to write a second version of this function as well, but we'll start with just this one. Okay, so what are we going to do? We're going to take in a string. So in our case, we have to take in a string because we're writing a static method and it doesn't already know about itself. So we'll take in a string as well as the position we want to start at in that string. We'll need to have our loop. Instead of starting at bucket 0, it'll start at the place in the string we want to start. Go all the way to the end of the string, building up our string as we go. All right, so we'll come in here. This will be static string substring, takes in a string s and an int pause. Okay, and we're going to start our string off. We can do error checking and make sure that the position they gave us is a legal position. You know, they don't pass you hello world and then say we'll start at bucket 90. But we'll assume they're passing us legal stuff, so we won't do error checking for this. So we'll have our normal loop for int I is equal to, but in this case, rather than starting at 0, the natural beginning portion of our string will start at position pause, whatever position they pass in and want us to start at. So we'll say pause. We'll still keep going as long as I is less than s dot length, and each time through we'll increase I by 1. All right, now what are we going to do each time through this loop? So this loop is going to currently take I on a voyage between pause and s dot length minus 1. Each time through, we need to capture the current character and concatenate it onto a running total, an answer. All right, so since we're building up a string, we're going to need an empty string to start with. So we'll say string answers starts off as the empty string. Each time through, we'll say answer. I don't know if we've done this syntax yet, but you can use the plus equals for concatenation as well. So this is answer is equal to answer concatenated with something else. And we'll say s dot char at I. So that line is equivalent to answer is equal to answer plus s dot char at I, like that. But it's treated as the concatenation operator rather than the addition operator because at least one string is involved. Okay. Ultimately, after our loop is done, answer should be the portion, the substring of our string that was passed in that we were looking for, and we'll go ahead and return that. Okay. So we'll test this. So we'll say string s is equal to hello world, and then we'll go ahead and say string answer is equal to driver dot substring, passing it s and passing it 6, and then we'll go ahead and say system dot out dot println answer. Okay, and if our algorithm is correct, we should get world out of this, right? So there's our world. Now, we might write a second version of substring. That is a version of substring. Let me copy this. That takes in a begin pause and an end pause. Okay. Now, this is more of a convention in programming languages than a rule, but typically things that have a begin and an end position, whether it's with strings or anything else, the end position is, as a general rule, non-inclusive. So if we say give us from position 0 to position 3, it would give us bucket 0, 1, and 2, not including the 3. Does that make sense? So don't take that to the bank for every function you ever run into, but as a general rule for, because nothing keeps a random person from writing one and they decide for their purposes they want end pause to go all the way to the position. But most programming languages that have a built-in begin-end thing, in a few minutes you can probably look ahead and understand. I'm probably going to show you the string version of these, okay? But I like to write them first so we can kind of understand what's happening under the hood. So we'll go up to but not including end pause. Okay? So that is to say, if we passed in hello world and we said take me from bucket 6, let's say take me from bucket 2 to bucket 7, let's say, for our 2 parameters, that's going to give us, that's 0, 1, 2, so that'll give us from here to 3, 4, 5, 6, not including the 7. So that'll give us LLO space W. Make sense? Now, before we will, let's go ahead and write it, and then we'll come back, because now we have 2 functions that have the same name, but a different number and or type of parameters. And that has a name. Let's just talk about it now, since I'm halfway explaining it already. So this is something in object-oriented languages called polymorphism. All right. So polymorphism means there is more than one function within the same class that has the same name but a different number and or type of parameter. All right. Now, an important aspect of that is Java does not care about what your variable names are for your parameters. Right? From Java's perspective, if you had a function called do something that took in an int a, and another function called do something that took in an int b, from Java's perspective, these are absolutely identical. And it will give you an error saying you've defined the same method twice. All right. Java doesn't care about the a and b. Those are just the variable names that dictate how you refer to your parameters inside the body of the function. All right. But on the other hand, if we had one that took in an int a and another one that took in an int a and an int b, these are different functions. Even though they have the exact same name, there's two versions. Java will decide which version you're referring to based on the types of parameters you send it. If you give it two numbers, it'll decide you mean the second one. If you give it one number, it'll decide you mean the first one. If you give it three numbers, it'll yell at you. You've called one that doesn't actually exist. All right, so this is a object-oriented term, polymorphism, that means more than one method with the same number and or types of parameters. And we've already experienced this when we looked at the, let's go back to the documentation here. Java.sun.com, Java SE, Java APIs. And we'll go ahead, go to java.lang to give us our base language. I'll go to the system class. Now we've used system.out.println pretty often, right? All right, so whatever out is, what would you expect to find in front of it since we're calling it with the name of the class? Be static. We'll find static in front of out, whatever it is, okay? Let's take it one step further. Whatever out is, when we get to println, println looks like it's a method function thing, right? It's got the parentheses on there. Because we're calling it with something that starts with a lowercase letter, that is out, we would expect that guy not to have a static in front of it. It appears to be called using an instance of something, right? So let's kind of follow that road down. So here's the system class. Inside of classes, there are really three things that could be members of a class. And I don't remember if we covered this yet, but let's go ahead and get it in the notes, just since we're talking about this. Members of classes. So classes have fields, they have constructors, and they have methods. All right. We've seen all these things at this point when we initially did our conversion from Alice to Java. So, but that was more of just seeing the conversion rather than doing it ourselves. Fields are variables owned by a class. Constructors are special purpose methods that build instances of a class. And methods are reusable chunks of code that we write once and can call multiple times with different inputs, something like that. All right, so these are the three types of animals, if you will, that we would find enclosed inside of a class, enclosed inside the opening and closing curly braces of a class. Out is going to be a field. All right, we constructors, and let's just add a little bit more to this. We're going to say these guys always have the same name as the class name in Java. Okay, that's not true in every programming language. Swift constructors are always called init, I-N-I-T. Java, it's always the name of the class, capitalization and all. C#, same way. C# and Java, you'll find extremely similar rules for pretty much everything. I would consider those to be basically the same language. Let's see. C++, same name as a class. C, classes don't exist. I should have asked that as a question. Let's see if I can get anybody tricked. Yeah. Procedural language, right? Objective-C, completely out in the blue. They don't differentiate between constructors and methods. So in Objective-C, it's fairly common to have a constructor called init with something, but not a rule by any stretch of the imagination. You could call a constructor Bozo the Clown if you wanted to. doesn't really matter. Okay, but constructors they look like special purpose methods, but they don't have a return type. So we might say that as well. Okay, and we'll talk about this a little bit more here in a few. Well, probably not in a few minutes. Probably next class or on Friday. But constructors have no return type, and the reason they don't have a return type is they are always called using the new keyword, and which we also introduced when we first were doing the conversion. And I usually refer to the new keyword as our real estate agent. Okay, we refer to it with arrays when we talked about arrays, and that guy goes and gets us memory locations. So that means constructors don't need to have a return type because they always return a pointer to where this object lives in memory, 100% of the time. So as a programmer, why should we have to waste our time putting something in there when the return type's always the same? And this actually, if we want to connect this back to something we talked about previously in here, when we talked about the evolution of C++ and then the evolution of Java, was we saw those grow up. One of the things we talked about in Java is that we removed the idea of a pointer, right? We talked about pass by value, pass by reference, and you know how in languages like C++, the programmer is empowered to either send something in by address or send something in by value, and that could have ramifications. I probably used the example in class of, you know, if you were inviting somebody to a party, would you give them the address where you live, or would you hand them your house? Is that probably the example I used? All right, so you know, we would always give them the address because handing them the house would be heavy, even for shot putters and those guys, right? You couldn't lift a house. Well, maybe one of those tiny homes.
Maybe they bought it on the house.
Well, actually, I saw a picture of that on Facebook. It looked like a pretty legit house. I mean, it was like a 2 or 3 bedroom house, wasn't it? Didn't you build it? You were there.
Yeah.
It was like, I mean, I'm not saying it was like a 5-star house, but it wasn't a little hut. It was a house that had size to it. Yeah, you couldn't lift that. Yeah, no way. Maybe as a class, we would nudge it. Probably not. They probably think they stapled down or something with the aboriginal bones or something like that. All right, so constructors never have a return type because they always are going to return a memory address. And that is kind of evidence of our evolution to Java, where Java removes some stuff from the language that we don't see. So Java doesn't require us to put in the return type for a constructor because the return type is always going to be the same. It's always going to be a memory address. All right, so these are the members of a class that we might expect to find if we're looking at the documentation. So the thing we're about to find in the system class is a field called out, and that guy is of type printStream, and we'll see that. And that guy leads to a class called printStream, and in that class we're going to find a whole bunch of methods that are called print and println. That is to say, a bunch of methods with the same name but a different number and or type of parameters. So polymorphism in action, so to speak. So here's the system class. Here's our field summary. Notice we have 3 fields in here. They're all print streams. Well, input stream that reads something in from the keyboard. But here's out, which is a print stream. So go and notice it has static in front of it. See, I have the time because of our crappy internet. You can do it. All right, so we scroll down here. We expect to find a bunch of non-static methods called print and println for printing out all the different kinds of types of things, printing out ints, bytes, longs, strings, objects. So here's a bunch of prints. Print starts right here. So print boolean, char array, double, float, int, long, object, string. This actually becomes kind of interesting, where when we do a print or a println on a char array, we might expect to see a pointer, but we actually see the contents of it. And let me just show that to you right now, since I have it up on the screen. So we've looked at arrays. If I create an int array called AR, and we just hard code that 1, 2, 3 like this. And then I create a char array called AR2 and have this guy be A, B, C. And then we say system.out.println AR, and we say system.out.println AR2, like that. AR is of type integer array. AR2 is of type char array. So before I show you the output of this, if we go back to the documentation, notice that print and similarly println below specifically knows how to handle char arrays, but it does not specifically know how to handle integer arrays. So integer arrays falls under the category of a generic object, this guy right here. So generic objects will call what I'll refer to this later on when we actually learn about this, but they'll call us a method that every object's guaranteed to have. It's a method called toString, right? And the default generic toString method that lives inside the object class boils down to a string representation of the memory address. So for our int array, we should see a memory address. For the char array, we're probably going to see something that looks like a string, because it seems like print and println have been taught when they were written how to handle char arrays specifically. All right. So we'll go ahead and run this, and we see crazy memory address for our integer array and a string looking thing for our char array. Make sense? All right, but this is in action. We can see our we can see polymorphism in action here. All right, so having said all of that, we're about to write a second version of Substring that takes in a begin and an end pause, and only gives us that little subset of our string. So we're going to say static string substring, and this guy will take in a string s, it'll take in an int begin pause. Now if I stopped right then and there, notice that Java can't distinguish between those two. I think those two functions are the same, even though I have one that takes in a variable called pause, the other one takes in begin pause. All right, there's end pause. All right, so now we're going to still have our answer we're going to build up. We're going to loop through our string from position pause all the way up to, but not including, well, position begin pause all the way up to, and but not including end pause. So we'll use our very similar for loop. I is less than end pause, I plus plus, and we'll say answer plus equals s dot char at I. Ultimately, will return answer. All right, so now we can call our other version of substring. So if we pass it a 2 and a 7, and then print out our answer, we'll go ahead and take these guys out of here. And we run this, we should get, what was it, L through the W. So LLO space W. Make sense? All right. So for your homework assignment, we'll write another little function. So we're going to have a function that returns a char array, and we're going to call this guy string to char array. This guy will take in a string s as a parameter, and it's going to return, and ours is going to be static since we're writing it in R. So if we took in a string hello, it should return a character array whose contents would look like H, E, yeah, pretend like those are commas, I guess. L, L, Oh. That makes sense? So you'll build a char array that is the same length as our string, and then fill it up with each individual element of our string. Sound good? All right. So I'll see everybody on Wednesday.